help you get those grades up a little bit. Because some of us have a decent kind of like classwork grade, but not such a great assessment grade, or vice versa. And so I want to kind of do stuff throughout, like this last month here, in both categories to help you get those grades up if you can. So what you'll see today is we'll do kind of two different things. We'll kind of recap last week a little bit. And even formalize some of the stuff that we learned along the way, just so you have it written down so we can always go back to it in case we need it. Because you'd be surprised how much we actually learned just by playing some blackjack for the week. And then we'll take some of those probabilities and kind of attach them a little bit. And play something different. I'll teach you a new game this week. It'll be a dice game. And we'll see the difference between what it's like to try to count cards in blackjack versus what it's like to kind of anticipate some things in dice, and what that means for us. And we'll actually have a dice. We'll see how it goes today, but I'm planning on having a dice tournament either tomorrow or Thursday, depending on how. We'll double elimination dice tournament. So the game's really easy to learn. You don't have to worry about counting anything. You just try to get lucky more than anything else. On that piece of paper, just put your name, today's date, and you can put like just probability up at the top, like probability rules if you want. There is some pretty straightforward kind of basic rules of probability, and you actually, I think at this point, probably know at least 4 of them, which is nice. What's up, Ken? So I think just having a spot, and you'll see in Canvas, there's a spot on today's announcement under modules or assignments. Well, you'll just upload whatever notes you take today. There'll just be a spot. I didn't really call it anything specific, probability notes so far, just to give you a spot in there. But what I want to do to help us kind of get there, so I'm going to bounce back and forth a little bit between this screen right here, and then I'll just go to the whiteboard and write it down. But I wanted to look at how we answered those questions from the week 11 reflection and see if we can come up with some rules that get there. But before we get to that, I'm going to start it off with some rules of our own. Okay, that kind of didn't really get answered on there. So definitely want to write these down. Probability rules. You already know, which is pretty cool. In no particular order, this is just kind of the order that I'm going to go in. But this is what you'll upload for me today for basically some free points to write stuff down. So that's awesome. So yeah, stuff on my desk. Actually, I got one that's sharpened right here. Though. I think this one. You got it.
The whole squad pulling up.
That one's broken. Use the black one to the right of Squishy's tank there. That one's good. That works. Yeah, somebody like knocked that super old pencil sharpener just off the table, and it just boom, just like exploded. That's from like 1973, so no surprise. All right, here we go. Think about a question that sounds like this. Now so don't write this down yet, but we did this, right? I asked you questions about like kind of some specific ones, right? It was like, what's the probability of getting a red card? What's the probability of picking a club? What about like the ace of hearts? What about an 8 or a 9? Well, and those all had different probabilities, like 1/2, 1/4, 1/13. They were all kind of like smaller parts of the whole because we had 52 cards. So let me ask you this. Get a deck, 52 cards. You pick a card. What's the probability that you picked a card? 52 out of 52, right? Doesn't matter what card I pick. Could have been a club, a spade, a heart, an 8, a 7, whatever. The probability of me doing something at most, right? 52 out of 52, because it doesn't matter which card I picked. Is there ever a chance that that probability is 53 out of 52? Like, could it ever be more than that? But what if I don't? 52 cards, you pick a card, what's the chance you picked a card? 52 out of 52, which is 100%. And what is 100%, or what is 52 out of 52 just as like a number? Like no percents, no fractions, 1. That is the biggest number we could possibly get, right? Okay. 52 cards, you pick a card. What's the chance that that card is a water bottle? 0. Could it be less than that? Chance of me picking something less than 0%? No, right? Bigger than 100%? No. That's the first rule. That when we talk about probabilities of anything, okay, it's got to be between 0 and 1. Okay, between 0% and 100%. Oh, those are the same thing, right? If I use percents or not, the numbers just kind of change a little bit between 0 and 1 or 0 and 100. The probability of anything has got to be between 0 and 1. And that's just kind of the first rule, that it can't be more than 100%. Can't be less than 0. That kind of makes sense, which I like. The nice part about probability is I feel like a lot of this stuff just kind of makes sense. Like in my mind, it just kind of clicks. So the concepts are nice like that, which I like. Okay. Second one. And again, this is in no particular order, so I'm going to do ones that hopefully kind of make sense. Now we get to those questions that kind of showed up on the reflection that a lot of us did really, really well with, which was really nice to see that most of us are getting this stuff right. So, a question like, what's the chance that I pull a red card? 26 out of 52. Chance of pulling a club, 91% and then 100%. That was awesome. How'd you come up with that? Keep it simple. Like, be obvious with your answer. That's okay. Which one? The club? Yeah. Well, what about the first one? Did you get that one right? Yeah, I think so. So how'd you come up with that? Yeah, there's only 2 possibilities. It's either red or black, right? 50% chance of doing one or the other. But I tried to kind of lead you there with this 26 out of 52, the 13 out of 52 to help you get there. Because, yeah, there's like 1 out of every 2 cards is red, but there's 26 of them out of the 52, right? Okay, so if the chance of pulling a red card is 26 out of 52, what's the chance of not pulling a red card? The other 26, right? Okay, so the chance of choosing a club, 13 out of 52. What's the chance of not picking a club? $39, right? The other 39 cards in the deck. And so let me ask you this. What's the chance of you picking a club or not picking a club? Pick a card out. What's the chance that it's a club or it's not a club? Think about it. I lay out all the cards face down, right? I pick it up. What was the chance it was a club? 25%. Right? And then what's the chance of it not being a club? The other 75, right? Okay. So what's the chance that I pick up this card and it's a club or it's not a club? Feels kind of tricky, right? So let me rephrase it. What's the chance that I pick this card and it's a club or it's a heart, a spade, or a dime? The other 39, right? So what's the chance that it's a club or a spade or a heart or a dime? For each one, what's the chance that it's one or the other or the other or the other? Good, good. And I want to kind of push you. That's why we're doing it. 100% chance, because it's all of, like, I give you all the options. I pull a club, or a heart, or a spade, or a diamond. Now, you kind of said it right, 25% chance for each one. So 25, it's a club, 25, it's a spade, 25, it's a diamond, 25, it's whatever I have to say.
Yeah, after you explain the order, what chance to get a card when you pull a card?
Right, and that's what I'm asking. But when they phrase it like this with like do I choose a club or do I not choose a club, right? What was the chance that I chose a spade versus not choosing a spade? Well, all right, it's either like the quarter of the deck over here or the 3/4 of the deck over here. Basically, what I want you to try to kind of get your hands on, like what I want to try to make sense is this whole like choosing a spade versus not choosing a spade. It's 25% or just the other 75, right? Red or not red, 50 or the other 50. Like, what's the chance of picking up an ace? Well, 4 aces out of the 52. Okay, so what's the probability of not picking an ace? Well, the other 48 out of 52. Okay, and that gets us to a rule. Okay, and I know it sounds a little confusing, and I apologize that I threw you off a little bit. But when we talk about this, like pick a spade or not a spade, can I pick a card that's both, like a spade and not a spade? Oh, it's got to be one or the other, right? I don't know if you guys have ever heard of this word before. But if we're talking about the probability of picking something, and so I'm just going to put something. I'm going to keep it simple. Okay. The probability of picking something is whatever percent. Okay, whatever it is, right? 25%, 50%, 1 out of 13, whatever it was. When we have these mutually exclusive groups, either I'm a club or I'm not a club, I'm an ace or I'm not an ace, I can't be both. It's called the complement. And not compliment like, hey, Traven, that shirt makes your eyes look nice. See how you look like you're blushing? Look at that, right? Complement with an I. This is complement with an E. Complement of something. The opposite. The other group is going to be 100% minus whatever this was right here. Right? 25% to pick a club. So what if I'm not a club? The other 75, right? 100% minus the 25. So the probability of getting something is some percent, right? Somewhere between 0 and 100. Then the complement of that is just the 100 minus whatever that was. As long as they're different, right? And there's a lot of things that I can be both, right? If I'm talking about like being a heart, I can also be an ace, right? Those two are not mutually exclusive. I could be an ace or not an ace. I could be a heart or not a heart, but I could be an ace that isn't a heart or an ace that is, right? And so those are not necessarily different. Okay, and so that word, the complement, is kind of what I wanted to show you. And there's some notation for that, okay? So let's say whatever I'm talking about, A, okay? Whatever it is, right? Something is going to happen. I'm just going to call that A, probability of something happening, okay? And I want the complement of that, okay? That's 1 minus the probability of A. Spade and not a spade, heart and not a heart, ace and not an ace. That comes up sometimes. Like sometimes I really don't want it to be a 10. So what's the probability that I get something that's not a 10? I want to kind of keep that in mind if I'm thinking about hitting this or doubling down or whatever it is. Kind of understanding those complements really actually help us do a lot. So that's pretty nice. All right, so we talk about mutually exclusive. Good. I'll give you a second to finish writing in case you still don't. Okay, but that little C up there, that just means the complement. That's what that is. And again, 1 minus or 100%, same thing. Doesn't matter. All right. Then something else came up, and I was actually really impressed. I thought we did a really nice job with this question up at the top right here. 83% of us got that right. What's the probability of choosing an 8 or choosing a 9? Somebody that got that right, if you remember, if you got it right. How'd you get that? How do you get 8 out of 52? What's that? Right, 4 8s, 4 9s. So how'd you get the 8? Addition, right? 4 chances of getting the 8. I know you're like, am I doing this right? Like it seems almost too simple, but you're absolutely right. Now the reason that works is because I can't be both an 8 and a 9 at the same time, right? That mutually exclusive group, that the idea of or, the chance of me doing this or that, all you have to do is add them up. Whatever those probabilities are, literally just add them together. Come on. All right, and so that's actually the third rule. And it seems really simple. Like if I wanted to get a 2, a 3, or a 4, right? If I need, like I don't want to bust because I got 17. A 2 is going to help me, a 3 is going to help me, a 4 is going to help me. Hey, even an ace could help me, right? 4 different possibilities there. Okay, 4 of these, 4 of these, 4 of these, 4 of these. Cool, 16 out of 52. Just add them up. And that's actually the third rule, that if I wanted the probability of this or that, 2 different things, right? So A is something, B is something else, and they are mutually exclusive. There's no overlap in their sample sets. Okay? Then it's just the probability of A happening plus the probability of B. That's actually the third rule. That if you have or, you see a word like or, then we're just going to add them up. As long as they're all different, which is nice. And those kind of make sense. Those kind of click really nicely for me. And just to kind of add on to this, again, it doesn't really matter the order that we do it. You know, what's the chance of picking a heart, a spade, a heart or a spade or a club or a diamond? That all added up to be 1. How should I say this? Let's say like the probability of A or B or C or dot, 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 as long as it fills out like all of them. So let's say this is all the possibilities in here. All the possibilities. Picking up an ace or a 2 or a 3 or a 4 or a 5 or a 6 all the way through king. Basically, what's the chance that I pick a card? Just 1. Probability of, and so when we talk about all the possibilities, that is called the sample space. All the possibilities, kind of fancy math terminology for that, the sample space. Just 1. Add them all up, right? Because picking a 2, all right, 4 out of 52. Picking a 3, 4 out of 52. A 4, 4 out of 52. A 5, 4 out of 52. Just add them all up. 52 out of 52. Sweet. Now, if I ever took any of those out, it's got to be less than 1, which kind of makes sense because my probability has got to be stuck between 0 and 1 somewhere, or 0% and 100%, whichever in your mind, whichever one works better for you. I'm good with either one. Some of us like the fractions, like the 1 out of 13, the 1/2, the 1/4, whatever. Some of us like 50%, 25%. Then you get to 1 out of 13. I'm like, what is that percent? I don't know. I don't know what 1 out of 13 is. So that's why I like to use the fractions, so I don't have to worry about like rounding and percents and results. Now the fifth one is the one that I knew we were gonna have a little trouble with, because I didn't give you a chance to like guess like which multiple choice answer was good, because I didn't give you a multiple choice answer. And it was, what are the chances you get black? All right, 52 cards get laid out, and I pull 2 of them. What are the chances that those first 2 cards are going to total 21? So I tried to lay it out like an ace and a king, or an ace and a queen, or an ace and a jack, or an ace and a 10. And now we have this idea of or. All right, well, if I could just figure out what it would take to get an ace and a king at the same time, and then an ace and a queen, and then an ace and a jack, or an ace and a 10, which are all the same probabilities, right? There's 4 aces and 4 kings, 4 aces and 4 queens. You know, so I just have to be able to add those probabilities up. But how do I do and? How do I do both? And that's the part that's tricky. And so I said, estimate this probability. Some of you guys just looked it up. If you don't know something, look it up. That's the age we're living in. That's what Sesame Street tells my daughter to do right now. Seriously. Elmo has a friend. Her name, Smarty. He's a smartphone. And Elmo goes, what do we do when we want, or no, Smarty says, what do we do when we want to learn something? We look it up. And they just like jump onto the phone and they look at kindness and friendship and farming and whatever. It's awesome. So it's okay that you look stuff up, but take a shot right now. Take a guess. And if you looked it up, don't guess because you'll spoil it. If you didn't look this up, what do you think the chances are? Aiden, what do you think? First 2 cards, an ace and a 10 card. So I lay out all 52 cards, and you get to randomly pick any 2 that you want. What's the chance that you have something that totals 21? So an ace and a card that's worth 10. Why do you say that?
Well, you have all of the suits, like 10.
Cool.
Jack, king, all those.
So there's a 10, a jack, a queen, and a king, and there's 4 of each.
4 of each.
So there's 16 of those. Okay.
And then I guess you have 4 aces.
So you got 4 aces, and you've got 16 other cards that we like. And I want both of them to happen. Right? I want to pull the ace. It doesn't matter what order we do it in. And so order would change things up. Order doesn't matter for us. That actually makes things a little simpler. So I'm going to pull a card first. I'm hoping it's an ace or 10. If it is the ace, then I had a 4 out of 52, so a 1 out of 13 chance to do that. And then after that, I don't want the ace again, but I want 16 of those cards that are left. 16 good ones, a bunch of bad ones. But you've already pulled an ace. How many cards are left? 16 good ones, but how many cards are left for you to choose from? So 52 cards total. You picked a card, 51. Nice, right? And so the question can kind of be a little confusing because, like, what you did to start makes a difference in how many cards are left. As soon as I pick a card, my probability changes, right? And that's why we kind of kept track of that count the whole way through. We have these issues with, like, that ace that I first pulled does not go back in the deck. So there's not really 52 cards left for me to try to pull from. Now there's 51 cards. I'm actually going to go to a new page because this one is worth talking about. The idea of and. I want to pull an ace and a 10. Jack, queen, or king, right? I want to pull an ace and at the same time, I want to do something else. Like, we're going to roll some dice. Like, I want to get a 3 and a 3. Like, I'm going to roll 2 dice, and I want them both to be 3s, right? That's going to be different than just saying, hey, I want 1 3. This idea of and can be a little tricky, especially in blackjack, which is why the game starts kind of simple, but the math behind it can get a little bit tricky. So if you want something like the probability of A and B, not just or, but and. So Aiden came up with a guess, somebody else, at least somebody else. What do you think that probability is of pulling an ace? So 4 out of 52, which is really just 1 out of 13. I'm going to leave a little space here because we got to do something. And then the next card, we only have 51 to choose from. We pulled one of the 4, right? That was my chances of pulling an ace. Now we got 16 of them, right? I don't think we can reduce that. I think that's just going to be 16 over 51. Can we do plus? No, plus was or, right? That made our chance is bigger. The chance of me pulling an ace and then pulling a 10. How many blackjacks did we see last week? Less than 5 total, right? A couple people got them, which was nice. Take a guess. What do you think that percent is? 10%, 20%, 50%, 1%, 20? Take a guess. 25.7. Anybody think it's more than that? 16%? Adding is not good because our numbers get bigger. Our numbers actually have to get smaller because we want 2 different things to happen. So we're going to take these 2 individual probabilities, and because they're fractions, we're going to multiply them together. If you want and, you multiply. If you want or, you just add them together. Now, when we multiply fractions, we just multiply straight across. So 16, right? 1 times 16. Somebody help me out. If you have your phone open, 13 times 51. Nikki, you got it. What you got? 13 times 51. 663? Yeah. All right, now do this fraction. 16 divided by 663, because I don't really know what that number is. 2143. 2413. 2.4. It's 2%, 2.5%. Those are your chances of getting more. This is what it is. This is the rule right here, that if you want the word and to be part of what you're talking about, multiply those individual probabilities together. But the thing for us is things had to change, right? It's not out of 52 again because there was some context and things that were happening. Okay? Now, the thing that we want to start thinking about, all right, so cards matter. Every time a card comes out, everything else starts to change. But if I'm looking at some dice, does me rolling this first dice affect the chances of what's going to happen with this dice? Are these events related to each other at all? How many sides are there on a dice? On a die? 1 die, 2 dice. 6 sides. So what's the chance of me rolling a 1? 1 out of 6. What about a 2? What about a 3? 1 out of 6, doesn't matter what, right? As long as these dice are fair, right? As long as these are good dice and there's not like, you know, a weight in there, or like, you know, somebody like coloring like in the circles is going to put like extra weight on them and might drag it down. As long as they're fair dice, it does not matter what I do with one versus the other. If I roll this one versus this one, order didn't matter. When I did it didn't matter. The whole out of 51 versus 52. These events are independent of each other. Okay? You do one, you do the other, doesn't matter. Okay? They are independent of one another. Okay? And the game that we're going to learn to help you deal with some of these probabilities doesn't use 2 dice, it uses 3. Okay, but I want to talk about 2 dice probabilities first. Or actually, well, wait, so we did 1 already, right? 1 out of 6 for each one. Okay, if you're rolling 1 die, I think it's DIE. Singular of dice. Thank you, internet. Die. Yeah. If you're rolling 1 die, 1 out of 6 chance for each. Right? Goes 1 through 6, just got little dots on them, you can count. Right? It's all about what's facing up. Roll it 1, roll it 5, 2, 2, 1. Doesn't matter what I did before. Like, you heard it in the movie 21, right? Blackjack is about the past and the present. Dice does not care about what happened before, does not care what happened after. This is really true, simple probability. And so what's the chance of me rolling a 1 or a 2? Well, 1 out of 6 plus 1 out of 6, right? Just add them up. But since we're going to be playing a game where what happens with all 3 dice matter, right? What's the chances of getting this and this and this? We're going to multiply those probabilities together, right? Because remember, when we're talking about rolling 1 die versus rolling 2, we're going to have to multiply probabilities together. So I'm going to even say 2 plus dice, multiple. 1 die, 2 dice, multiply those probabilities. Okay? And the game that we're going to play, you can spell it a few different ways. I don't know if you've heard it. CeeLo. Anybody ever played CeeLo before? Super simple. Yeah, that's why we're doing it on that shorter week, because we watched the video and we talked a little about some stuff. Okay. The game that we're going to play is called CeeLo. Actually, I think they spell it. That looks like CeeLo. I think it's CeeLo with a W. I played baseball in college. We used to take long bus rides for like weekend road trips to go play. We play CeeLo in the back of the bus for dollars all the time. Now, we're not going to play for real money, but eventually we'll have some chips in front of us. Maybe later this week. But I want to teach you the game first. It's very, very simple. Okay? You can play with as many people as you want. As many people as you want. Okay? You have to have, let me go to a new page, I guess, so I can write some stuff down. Okay? CeeLo. Okay? 2 or more players can play. Okay? 3 dice each. And depending on what you roll, only 1 person can win each turn. Okay? And so what will happen is each player will roll their 3 dice, and depending on what's facing up, it kind of decides what hand they've got. Like, what's your score? Okay? So you roll all 3 dice at the same time. Now, sometimes, depending on how many dice we have, maybe like every player would roll all of their dice all at once. So it would just be kind of like crazy. Like we'd have green dice, we'd have yellow dice. We'd like, maybe we've got like 3 people playing, so we'd use 3 different colors, something like that. Or you roll yours, then hand it off. Doesn't matter. Okay. Here's how you win and lose. Okay, if you roll a 4, 5, 6. Exactly. A 4 and a 5 and a 6. You automatically win. Automatically you win the game. Okay, if you roll a 1 and a 2 and a 3. Automatically lose. Okay, 4, 5, 6, best roll you can get. 1, 2, 3, yours. So let me ask you this. What's the probability of rolling a 4 and a 5 and a 6? 4 and 5 and 6. Well, let's just talk about this one first. What's the probability of rolling a 4? Okay. What's the probability of rolling a 5? What's the probability of rolling a 6? And what do we do with the word and? Multiplication. Multiply tops the other one times 1 times 1. Nice. Bottom 6 times 6 times 6. Deon's got it.
116.
Okay, that is less than half a percent chance. 1 out of 100 would be 1%. This is more than 1 out of 200. Okay, so an auto win, pretty unlikely, but it can happen. I've seen it many times. Okay, what about rolling a 1 and a 2 and a 3? Thank you. You have the exact same chance of winning automatically and losing automatically because rolling a 1 or a 2 or a 3, they're all the same chance. But the chance of getting all of those, we got to multiply those all. So pretty unlikely. Okay? Everything else, okay, has kind of a ranking to it in between. Okay? If you roll them and there's nothing, like there's no pairs and there's no trips, and it's just kind of like 1, 5, 3, 2, 4, 6, 4, 5, 1. Like there's nothing in common and it doesn't come in this order, that doesn't qualify as a hand. Okay? You've got to roll again if you don't get at least these two or a pair. You got to have at least a pair. Okay? And so the ranking goes according to that. Okay? So the possibilities after this are pair, or what I'm going to call trips. It's more of a poker terminology, but we're going to use it. Okay, trips is 3 of 5. So maybe I'll put that. Okay, 3 of 5. All 1s, all 2s, all 3s, all 4s, etc. Okay. Any trips is going to beat any pair. But they go in order. 3 6s is better than 3 5s. 3 5s is better than 3 4s. 3 4s is better than 3 3s, and on down to 1. Okay. So the best hand after 4 5 6 is 6 6 6. Then 5 5 5. Then 4 4 4 3 3 3 2 2 2 1 1 1. Okay. So anything below 4 5 6, you're looking for 3 of a kind. But if you don't get 3 of a kind, you can still get a pair. But the thing about a pair is that it's not the pair that matters, it's the other one. So if I did this, okay, if I did 2 3s and a 2, that was my roll. 3s don't matter. Your score, your points, whatever, you have a 2. Okay? And so 2 3s and a 2 loses to 2 3s and a 5. Because 5 is bigger. 6 is bigger than that. But hey, if I did, let's see, 2 4s and a 1, what's your number? What's your number there? Just the 1. So 2 3s and a 3, 2 3s and a 6 is going to beat 2 4s and a 1 because the 6 is bigger than the 1. I don't care what these are. Okay, so when we talk about pairs, okay, let's call it the singleton is what counts. Okay, the one that's by itself. Okay, 1 is low, 6 is high. Okay, any trips beats any pair. Okay, same thing for trips though. 1 is low, 6 is high. And you want the best hand you can get. 4, 5, 6, 6, 6, 6, 5, 5, 5, 4, 4, 4, 3, 3, 3, 2, 2, 2, 1, 1, 1. Or pair with the 6, pair with the 5, pair with the 4, pair with the 3, pair with the 2, pair with the 4. Okay, and what I want to try to do today, just so you can kind of get a chance to try it, see if I can keep these separate. We only have 5 minutes, so I just want you to play today, so you know how to play tomorrow. But we're so short on time. You know what? We'll just do it tomorrow. We'll just learn how to play tomorrow, and we might be able to just knock out the tournament tomorrow as well. Folks at home, you guys are going to participate as well. We'll just roll for you, okay? But I'm going to put a bracket together, and you guys will definitely be able to play, okay? But if you are going to play, I have to be able to hear from you, so I know that you're actually there. So when I set up the bracket, I have to know that you're here and you're going to be here so I can do that. Okay, so we'll make sure that we're good to go there. Okay, so we'll have some dice. Right, I'll have them in my hand. I'll roll them out for you. I'll make sure the camera's looking good. All right, well, we'll stop right there. I think that's good for today. We did lots. Hey, whatever you wrote down today, put it on canvas right now so I can get the point. I know. Sorry. Yeah, so there's a spot on today's announcement, or modules, or assignments, whatever you want. Okay, probability notes so far. Okay, go on to canvas, just drop it. Take a picture of whatever you did today, drop it on canvas. Tomorrow we'll learn how to play it. We'll deal with some probabilities. We'll see if we can set up the bracket. We'll do double elimination, heads up tournament.
Cornhole and pizza, that's the view.
Yeah, it should be fun.